Attention to all junior high school students. Please proceed to the main lobby as the grade 9 learners will be picking out 50 sample respondents for their research. Thank you.
Sana ako mapili nila. Ako top 1 ng klase, baka ma-perfect nila yung research nila. Abay, sino naman nagsabi na ikaw pipili nila? Malamang ako pipili nila. Ang macho-macho ko, mamaya ma-fall pa sila sa akin. Kay Rita, magsitigil na kayo dyan. Talo kayo ng talo eh. Alam niyo naman akong pipili nila. A pleasant morning to you all. I'm Brent A. Gonzalez, a grade 9 DXP student, and today I'll be picking out 50 sample respondents for our research. So, Teacher Freda, kompleto po ba lahat ng 251 junior high school students dito sa campus ngayon?
Oo anak, kompleto lahat.
Thank you po. Okay.
Ako pa pagbibilangin. Kirita.
So, in picking out the 50 sample respondents for our research, we will be using systematic random sampling. So, this systematic random sampling, hindi lang kami kukuha ng 50 sample respondents. Pero tuturuan ko rin kayo kung paano gumamit nito. So that you can use it for future references, or kung nag-research kayo at kailangan nyo rin ng sample respondents, you can use this sampling technique. So, let's start. What is systematic random sampling? Systematic random sampling is a random sampling technique in which sample members from a population are being selected according to a random starting point, but with a fixed periodic interval. This interval, called the sampling interval, is calculated by dividing the total population size by the desired sample size. Ganun pala! Piliin niyo ako! Oops! We're not done yet. We're actually just getting started. Now, let's proceed to step number 1 in using systematic random sampling. Step number 1, prepare the sampling frame or the list of the total population. Here is the prepared sampling frame of the whole 251 junior high school students of Philippine New Chao School. Step number 2, we will assign each sample a number. Since there are 251 students in the sampling frame, the range of the assigned numbers should be from 1 to 251. Step number 3, we will find the sampling interval. The sampling interval is the interval that will be later used to determine the samples. So here's how to get the sampling interval. The formula for getting the sampling interval is equal to the total population over the total number of samples needed. For our case, the total population is 251, while the total number of samples needed is 50. Let's compute. 251 divided by 50 is equal to 5.02. But because there's no such thing as 5.02 samples or 5.02 sampling interval, we will round it off. So the sampling interval is every fifth. Step number 4, we will select a number from the whole numbers between 0 and k plus 1 by simple random technique. For our case, since the value of our k is 5, that means that k plus 1 is equal to 6. Using this simple random technique, we need to choose a whole number between 0 and 6. The numbers between 0 and 6 are 1, 2, 3, 4, and 5. We can either use the fishbowl method or by using a random number generator by setting the minimum to 1 and the maximum to 5. The number that we have ended up with is the number 4, and this number is called the random start. Step number 5, we will select every fifth element from the sampling frame, starting from the random start number that we got from the previous step, which is number 4. The highlighted names in our sampling frame are our sample respondents. So that's how you choose your sample respondents using systematic random sampling. Now we will be announcing the lucky 50 sample respondents that will be participating in our research. First is Sana ko. And for our last 3 sample respondents, we have Aiki Tabayoyong, Mark Ferrer, and Margaret Bartolome. Congratulations to you all! And that's where our episode of Edu Statistics ends. I hope you have learned a lot from this video. Make sure to like and share this video and to subscribe to my YouTube channel so that you will always be notified with the daily posts of Edu Statistics. Thank you for watching. Bye!